All right. Hello guys, how you guys doing? So this is my special, and today we'll be looking at dimension analysis. And if this is your first time you come to my YouTube channels, kindly subscribe and share this video, and also turn on a notification bell in case I post any video. You'll be always, you know, get notified. So today we're talking about dimension analysis. That is on how to solve question dimension. You can actually solve question on dimension analysis. You can solve question in terms of if you are given something like this, maybe you are given A is equal to what? B, C. And they now asking you that okay, what is the unit of, assuming that B is constant. Assuming that what B is constant, what is the unit of what of B? That means I'm going to divide both sides by what? By C, right? That means I'm going to have what? B is equal to what? A over C. Now they now tell you that A is meter and C is seconds. So please, what's it going to be? It's going to be what? Meter per second. That means the unit of B is what? Meter per second. Number one, so that means you can either solve a question like this, or they will ask you in another way. They can ask you to check whether this equation is correct. They can ask you to check whether an equation is correct, right? And that means maybe okay, let's assume that you are giving A is equal to what? A plus B, no, A plus C. Now everybody know that A and A they are the same, right? That means let's assume that their units are the same also. Maybe you are giving meter is equal to what? Equal to meter. Now they now gave you, that means they now gave you this guy to be meter per second square times second square. That means like maybe let's assume that this is the unit for C, meter per second square times second square. Please, what are you going to do? That's going to be what? Meter is equal to what? Meter plus meter, that is h power minus 2 plus what? Times the what? Plus 2. That's going to be what? Meter is equal to what? Meter plus m raised power what? Minus h power what? 0. That means, and any raised power 0 is what? Is 1. That means this one has what? You can see. That means you can, so you can also solve the question like this also. And also they can also ask you to, maybe you are given an equation, maybe you are given this type of equation, maybe you are given C is equal to maybe like kilogram and density. They now ask you to prove whether this equation is correct. So they will be asking you what is x, what is y, what is z. That means they can ask you question in these three aspects. The first aspect is that they can ask in terms of if you are given A is equal to what? B, C, right? They ask you to look for B, or they can ask you to look for whether this equation is correct. That is whereby my right hand side is equal to what? My left hand side is equal to what? My right hand side. And they can also ask you, maybe they give you this equation, they now ask you to look for x, y, z. That means they can actually ask you a question based on these three aspects. And I'll be solving those 4 questions to 3 questions depending on the time. So let's try for, so let's start from the first one. Second aspect is that if you guys remember that I give you something that if you have a plus b, right, that they will ask you to look for whether this question is correct. Now let's assume that we are given x is equal to ut plus half at squared. Now one thing that we don't do in dimension analysis is that we don't consider a constant. We don't consider what a constant when you are solving. Now everybody, what is the unit for distance? Distance is what? It is meter. What is initial velocity? Meter per seconds times what? What is time? Seconds. Plus what? What's acceleration, everybody? That's what? Meter per second square, right? Times what? What's time? That's second square. That's going to be what? Meter is equal to what? Meter per second. Since I have one here, and in the law of indices, say that what? Whenever I'm having multiplication, that means I'm just going to pick one of them. That's going to be what? Minus 1 plus what? Plus 1, right? Because there's 1 here. Plus meter is power what? L is power what? Minus 2 plus 2. Remember, that's going to be what? Meter is equal to what? Meter is power 0 plus what? M is power what? M is power. And n is power 0 is what? It is 1. That's going to what? M is equal to what? M times 1 plus what? M times 1. That's going to what? M is equal to what? M plus M. So this is the aspect. So let me give you another one so you can just remember by yourself. Let's assume that you also giving something like this. V square is equal to what? U square plus 2s. They are telling you to check whether this equation is dimensionally correct. How will you check? Velocity is always what? Meter per seconds, right? All square. Because there's square here. That's going to be what? Meter per second also. All what? All square. I told you that we don't consider a constant. What's acceleration? Acceleration is what? Is meter per second square. This S here represents what? Represents distance. Distance what? That is like this S. So for this one, we don't consider what a constant. So this my acceleration is what? Is meter per second square times what is distance? Distance is also what? Distance is also what? Distance is also m, right? Now here let's go. So this two, that's going to what? Meter per second square, because minus one times two is what? Is minus two, right? It's got what? Also the same thing with this. Minus one times two is what? Is h power minus two, right? Plus meter times meter is also what? Meter square. H power what? Minus two. Explain how we got the formulas and units for each aspect. Now velocity is meter per seconds. Initial velocity is still the same thing as what? As meter per seconds. Acceleration is what? Is meter per second square. Time is what? It is seconds. So if you know all these ones, you are good to go. Now let's dive into it again. So let's go. We have V is equal to what? It's equal to U plus AT. What's velocity, everybody? Velocity is what? Is meter per seconds. What's initial velocity? It's also what? Meter per seconds. What's acceleration? That's what? Meter per second square. Everybody, what's time? Time is what? It is seconds. I told you that the condition is that we just want to check whether this equation is correct. And one of the ways of checking whether this equation is correct is that you check that if your left hand side is equal to your what? It's equal to your right hand side. Now let's check. We have what? Meter per second is equal to what? Meter per seconds, right? Plus, now anytime I have these two things, this thing in mathematics is called what? Is called a base. That means I have to pick one base and I will add the power. Now since I'm having multiplication, it's going to what? Positive. So it's going to be what? Minus 2 plus 1, right? Because there's a 1 here. So let's go. We can have what? Meter per second is equal to what? Meter per second plus what? Meter per. Now I'm having 2 naira. Like I'm owing someone 2 naira and I have 1 naira with me. That means what? Since I'm already owing the person 2 naira, that means I need to give the person what? 1 naira. So I'm still owing the person what? 1 naira. That's going to be what? Minus 1. You can see from this aspect that what? My left hand side is equal to what? My right hand side. That means I'm able to prove that this equation is what is correct. And if I want to write it dimensionally, I've already explained in my previous video that whenever you add the word meter is what? Is L, capital letter L. S which is second word is 3 raised by what? Minus 1. And L is what? 3 raised by what? Minus 1. Plus what? L is what? 3 raised by minus 1. So this is what? This is dimensional what? Correctly. This is dimensionally what? It is dimensionally, what? Correct. Are you guys getting my point? So this is the first question. Now let's dive into the second question immediately. That wastes our time. You can have V square is equal to what? U square plus 2AS, right? And since I have V square equal U square plus 2AS, everybody know that velocity is what? Velocity is meter per second all square. Equal to what? Meter per second all square. Plus what? I told you, whenever you are consider anything that has to do with dimension analysis, we don't use what? We don't consider a constant, which is 2. 2 is a constant here. So we are going to neglect these two. And this S here, S represents what? Distance here. S represents what? Distance, which is what? Which is meter. A represents what? Acceleration. Everybody, what's the unit for acceleration? Meter per second square. In case you don't know how I get my meter per second square, you can go back to my previous video and watch it. Now, what is distance? Distance is what? Is meter, right? So I'm going to have what? Now, since I'm having square, this square belongs to everybody that is here. So it's going to be what? Meter per second what? Meter per second square. I get my point. That is 1 times 2 is what? Is like minus 1 times 2 is what? Is minus 2. It's equal to what? Minus 1 times 2 is what? Is also what? Is also minus 2. Time plus, right? Now I'm having 2 meter and this thing means what? It means meter per second square times what? Times meter. Now if I'm having meter per second square, that means meter times meter is what? Is meter square per second square. So I can have that meter per second square is equal to what? Meter per second square. You can see that I've already proved this thing as what? This thing is also what? Is also dimensionally what's correct. And if I want to write the dimension analysis of it, is what? Is L t raised to power minus what minus 2 is equal to what L t raised to power what minus 2 plus L square. Yes, L t is power what is power minus 2. Yes, so this is what this is dimensionally what this is dimensionally correct. Now let's go to the next questions. Now you can be asked a question. If you are given this question, let's assume that you are given f is equal to what f is equal to let's assume maybe kgm1, oh sorry, gm1 m2 over r square. Now your exam will always give you like this, that look for x, y, z. It's actually very very simple. Look for what x, y, that is they are trying to ask you to what to look for these questions, like to look for what x, y, z. And for you to get that, everybody all know that what my f is what f is force, right? This is mass 1, this is what mass 2, and this is what and this is distance r square. Now how can you look for your what how can you look for this x y z x y z? Now it is only very very what it is only very very simple. And now how can you do it? Number one, do you know that everybody knows that what gravitational this is what gravitational constant? Do you understand what gravitational constant? Do you represent the gravitational constant? And I told you guys that we don't consider what constant when calculating this aspect, right? That means we are going to make what g the subject of the formulas. Everybody, yeah, let's cross multiply. Now, if I cross multiply, what am I going to have? I'm going to have what something like this, right? I'm going to have f times what r, so that's what f r squared. I'm going to have what g m1 m2 having a right times 1 that is here, right? But we don't need the 1. Now let's divide both sides by what by m1 m2 because it is stopping what this g. So it's going to be what m1 m2 over what over m1 m2, right? Now if I cancel these two things, I'm going to have this thing left, right? Now everybody all knows that g is equal to what fr square over what over mass 1 and what and mass 2. And everybody know that what the unit of what of mass is what is kilogram, right? What of the unit of force? The unit of force is what is kilogram meter per second square. Again, if you don't know how I get kilogram meter per second square, go back to my previous video and watch the video. You will see how it is being done. Now this my r here represents what my meter, and like this r represent what distance, and the unit of distance is what is meter. That's going to be what times meter square over what mass times mass, that is kilogram times kilogram, right? Kilogram times what times kilogram. So we can now have that what g is equal to what is equal to kilogram meter per second square times what times meter square over kilogram times kilogram is what is kilogram square. Kilogram what kilogram square. So we can have kilogram over what over kilogram square, right? So since I have two here, so one can go here, and that means we have one left. That's going to be kilogram is equal to if this kilogram go up, that's going to what per kilogram. Meter times meter is what meters times meter square, that's what meter cube per second square. That is going to be what is the dimension for m for kilogram is s per minus s per 3 and 1 3 per what minus 2. So my x can be minus 1, my y can be what can be 3, and my z can be what minus 2. So that is what about. If we have x is equal to ut plus half at square. Now in this aspect, we are trying to show that my left hand side is equal to well, it was for my right hand side. I told you guys that we don't consider this as constant, and constant here is what is 1 over 2. Is what is 1 over 2. Constant that is there. Now everyone know that distance x represents distance here, and the unit for distance is what it is meter. Now what the unit for your initial velocity, that's what meter per seconds times what's time seconds plus we don't consider what constant. What's acceleration? Acceleration is what is meter per second square times what's time. Time is what the second square. Are you getting my point? Everything we are trying to do that we want to try to make sure that all this place every other thing here is what is meter, because my left hand side is equal to what it's equal to meter. So is that going to be what meter is equal to what meter per seconds. Now we have one here, right? And multiplication will turn to what positive. That's going to be minus 1 plus what plus 1 plus meter per second square minus 2 plus what because there's plus times there, that's what plus 2. So we have what m is equal to what meter per second, or minus 1 plus 1 is what is 0, because I'm owing someone 1 naira and I have 1 naira. So if I pay the person my 1 naira that I own the person, so I will have nothing left. Time plus what x raised to power what minus x raised to power 0, same thing with this. And anything raised to power 0 is equal to what, equal to 1. That's going to be what meter is equal to what m x raised to power what times 1, right? Plus what m times what times 1. That's going to be what m is equal to what m plus m. And the dimension is what is l is equal to what l plus what plus l. So this is what, this is dimensionally what, this is dimensionally, yeah, this is dimensionally correct. Are you guys getting my points? So let's try to move forward again. If you are given C, is actually very what, very easy. Now, how can you solve this question? Please try to write it down, because I'm going to clean it up now. So now, that means you are given what C is equal to what 80 all raised to power 3. So now they tell us that this guy is called specific what, is specific what, heat capacity, and this guy is what is temperature. Now they are asking us to look for what? To look for this constant A. So it's going to be what? Everybody, let's go. C is equal to what? 80 all raised power what? 80 all raised power 3, right? Now if I have C is equal to what? 80 all raised power 3. Now, since I'm looking for my constant A, that means I'm going to divide both sides by what? By temperature. 3 raised power 3, 3 raised power what? 3 raised power 3. Chop, chop. So everybody, what do I have left? I have what? A is equal to what? C all raised power 3 raised power 3. And now what is my specific capacity? And if you guys can remember very well that specific capacity is the amount of heat required to raise the temperature of a mass by 1 degree Kelvin or Celsius. Are you getting my point? That means now the first thing that you have to do is amount, you have to look for the unit for specific heat capacity. And everybody know that anything that is energy means what? Heat means energy, right? And everybody, what is unit for energy? Energy is what? Is force times distance, right? What is the unit for mass? That's what, that's, we have mass times what? Temperature is what? Is in Kelvin, right? Now let's go. We have C is equal to what? Everybody, what is the unit of force? If you can remember from our last video, you see that unit of force is what? Is kilogram meter per second square times what? What's the unit for distance? That's what, meter, over what? What's the unit for mass? Mass here is what? Is kilogram times what? Kelvin, right? That means I can divide this one. I can say that kilogram cancel what? Kilogram. So what did I have left? I have, like, what did I have left? I have what? Meter times meter is what? Is meter square per second square. This one over what? Over Kelvin. Are you guys getting my point? That means, do you know that I cannot have that what? I cannot have that. So that means I can have that what? That C is equal to what? M square raised power minus 2 over K. That's going to be what? C is equal to what? M square raised power minus 2. That means this K will go, that's going to be what? K raised power minus 1. I get my point. So the dimension will be what? C is equal to what? L square 3 raised power minus 2. K doesn't really have dimension, so it is still K raised power minus 1. Answer.